Hi, welcome to this session. I'm going to talk about RxJava and reactive extensions in a practical way. So the idea of this talk is to introduce you to RxJava and the concepts behind RxJava. So if you are a beginner, it's perfect. It's an adaptation from a workshop that I've been doing lately. So we try to put some context around RxJava operators. My name is Simon. I work for Couchbase. So if you want to maybe apply what you learned today, know that the Couchbase Java SDK is fully reactive and using RxJava behind the scene. So you can have a data source that is using RxJava, which is cool. And let me talk about the plan for today's session and the goals. So we are going to learn about RxJava 101, so the basics. We are going to do that by migrating a legacy application, taking that as an example. And of course, we are going to learn about the main operators of interest in RxJava, and do that through 9 steps that I will walk through with you. But first, why? Because blocking is evil, okay? Today we need to write asynchronous code, code that is reactive, buzzwords I know, parallelizable, that more importantly can be composed easily. That's very important. And if you compose it efficiently, then it's more readable. And readability of your code is arguably the most important thing, right? So how can we do that? In Java, in the JDK, you have basically 2 solutions to write asynchronous code. You have callbacks and you have futures. Well, you have completable futures in Java 8, but since then, until then, I mean. And both of these have their own problems. So futures, let's talk about futures first. Futures it's far too easy to revert back to a blocking behavior with futures. The first thing you are tempted to do when you use a future is just call get, and then boom, you're blocking again. And of course, beyond one level of composition, futures start to show their limitation. And let's not even talk about callbacks about that. I mean, callbacks, they have no composition at all. And have you heard about callback hell? Raise your hand. Yeah, this kind of thing. Okay, when you see code going far to the right like that, because you are calling a callback inside a callback inside a callback, because you have multiple dependencies between your asynchronous services, it's just a nightmare. Your head explodes. So I think that RxJava is kind of an answer to that. It can be a way out of callback hell. This is the nice little logo for RxJava. RxJava is a project that has been open sourced by Netflix, but originally the inspiration came from the .NET ecosystem with reactive extensions by Eric Meyer. So someone at Netflix was looking at a new paradigm to do asynchronous code more easily and without having to read concurrency in practice from start to finish. And he saw reactive extension and said, oh, okay, this is a good idea, but we are working with Java code. So they ported the IDs and the libraries to Java. It can be seen as the duality of the iterable-iterator couple. So in RxJava, iterable-iterator, it becomes observable-observer duo. And iterable-iterator, it's a pool model as the developer, you are in charge of telling the collection, okay, give me your next item. I want it now. You are piloting the iteration through the collection. In RxJava with observable observer, it's a push model. So you will subscribe to a stream and you will receive notifications. So the source of your data will emit items and notify you of new items. And beyond that, beyond being notified of new items that come in, RxJava allows you to compose. And compose what? Compose asynchronous programs that are based on events, basically. Because you are using observable sequences. And you will chain operators, combine these sequences with one another, and obtain an asynchronous stream of processing, basically. Okay. Interesting reads. There is a manifesto. There are a lot of manifestos, but there is the Reactive manifesto, which is an interesting one, which exposes a way to architect your applications so that they are more resilient to failure, that they are more efficient with the data they process. And RxJava is can be part of the picture to develop a reactive application in the sense of the Reactive manifesto. So you can go to this URL and read about what does it mean to be a reactive application. There's also the reactive streams, which is an attempt to standardize on the JVM. First, it was outside of the JDK, but this morning there was another session where they told us that this will actually be part of JDK 9. So it's a standard of some of the ideas behind RxJava. And there are three main implementations: Akka, Streams, Reactor from Spring, and RxJava. But RxJava has been around for a bit of a longer time, so there is a more diverse API. So RxJava offers lots of operators, and Reactive Streams is just specifying the publisher-consumer side of things, and something called back pressure, but we'll come to that later. So okay, this is quite abstract for now, so you want me to show you how it works, I guess. And it's quite simple. This observer is a simple interface. It has three methods. OnNext. OnNext is the method that gets notified when there is a new item emitted in the stream. OnCompleted, at the end of the stream, when the source has no elements, any remaining elements to emit, it will signal the stream and tell the consumer that it's complete. And there is error handling with onError. So you get notification of any exception that occurred during the processing of your stream, and it's propagated back to you in the onError method, which is a terminal event. So after that, the stream is finished. So the contract basically is I will receive n calls to onNext, followed by at least one, either onCompleted or onError. And after that, I shouldn't receive anything more. And okay, so far so good. And of course, the other side of the picture is observable of T. And you use, so this is your stream of data. This is your source of data. But also, this gives you a way of describing what you want to do with the data. If you want to transform it, if you want to combine it with other sources, if you want to maybe manage errors in a different way. So basically, it allows you to compose and chain a stream. And at the end of this chaining, you do a subscription. So you subscribe an observer to your observable stream. And in the observer, you will basically describe what is the end consuming of your data. So what do you actually want to do with the final form of the data? And about operators, there is a ton of operators, so much choice. Okay, so you are probably still a bit lost. It's time to get to the practical part. What we'll do today is work on a legacy app. Legacy as in Spring Boot and Java 8, of course. This is an app for the future. It's an app that manages a pool of miners for some cryptocurrency called Dogecoin. But that's just a pretext. And the architecture is a bit like that. So here we have the legacy app, which is a REST API, basically. So Spring REST controllers. And then we have services that talk to each other and also depend on external APIs. So they are making REST calls to external APIs for things like what's the current exchange rate of dollar versus euro, for instance, and stuff like that. And they also store some data in a database, in this case, a Couchbase. Let's focus on the legacy app. So yeah, that's what I was saying. We want to, so we have REST controllers from Spring. And these services, first, we want to migrate them to observable services. So make it so that instead of returning, some of them return doubles or lists of users and stuff like that. We want to transform these so that they return observable of double, observable of user, so that after we can compose them more efficiently and benefit from what RxJava has to offer. And of course, if we migrate the backend, we also want to migrate the services themselves so that we are asynchronous from end to end. Okay? Yeah. So when we start such a project, we have legacy code or existing code that is blocking all the way, and we want to migrate that to an async way of doing things. And of course, this can be a big bang instantaneous migration. You can't do that and, oh, yeah, I have reactive services. So you have to take baby steps. And I think the first step is how do you actually create an observable? If you have a method that generates a double or extract a user entity from your database, how do you make it an observable of user? And the simplest answer to that is that on the observable class, you have factory methods. And you have methods like just, from, create. For instance, just, it will capture a value that you give to it as a parameter. For instance, just new user. And it will return an observable that emits this single item. From is the same, but with a collection. So if you have a list of data and you want to transform that to an observable of data, you just pass the list to from, and you obtain an observable out of it. And also, quite quickly, you will probably want to transform your data. So it's time to learn our first proper RxJava operator. Anyone in the audience is has been doing functional programming, maybe? Okay. Okay, so this is one operator that is familiar to people that use functional programming, but it's in Java, thanks to RxJava. So the idea of map is that you have an input stream of marbles, and you describe a map function, which is your transformation, and it will apply this map function to every item in the source observable to produce an output observable. So here we see that when it receives in the input observable, when it receives a red marble, it will pass it to the map function, which transforms the form into a diamond, and it will emit a diamond. So what you get as an output of that is an observable of diamonds of the same color as your input. Let's try and see a quick example of that. So I'll switch to mirroring. Okay. Please do tell me if it's too small to see. So I have a class here called admin service, and I'll just show you the initial state. So in the admin service, we have a cost for month method, which returns a big integer. And well, it's quite naive of an implementation, but basically, if it detects that the parameter that you gave to the method correspond to the current month, it will just return 0, a constant, and otherwise it will compute a value and return that value. So what we want to do actually is start the migration to observable by making return an observable, the correct one, Rx1, an observable of big integer. And then, since it's a naive implementation, we can just use the factory methods I was telling you about. So in this particular case, we'll return we'll return an observable that sees only one item emitted, which is big integer.0. Same here. Observable just big integer.0, and basically same here. And yeah, we could use the just factory method here as well, but we see that it's kind of a transformation of the parameters, and we use a multiplier. So actually, maybe it's a good point where we should use map, right? Oh, I should be in presentation mode. Sorry about that. That should be. Oops. Okay, so I just switched to presentation mode. That should be. Is that better? Yeah, I think so. So what we can do in here to apply the map operator is just start from months.getValue, observable just months.getValue, and then do a map. Is everybody comfortable with the Java 8 Lambda syntax? Yeah? Okay. So we want to do a map from integer to big integer. So this value we will multiply by 100. And then we can do another map. Oh, yeah, we can maybe do that plus. So. And do another map from integer to new big integer. Well, that's kind of a trivial example, but you get the idea that you get the idea that we want to transform something so we can use RxJava operators for that. And this is probably because there is a factory method. Yeah. Oh yeah, in line 25, right, thanks. Sorry? Yeah. So yeah, here we are saying that we are constructing a stream with just one element, which is the value of the months parameter. And then we want to transform that. So we want to map each month parameter to a particular computation here. So year plus v times 100. And then since we want an output of a big integer, we convert it to a big integer. Actually, maybe if I maybe if I show you one of the So yeah, originally I went in another direction while I just used map for the deal function, but okay, that's just confusing, I think. So yeah, map transforms the data that comes into your input stream, and it gets applied to each new item and produces a corresponding transformed item. This will get clearer afterwards, I think. It's no, it's not the streams JDK map. It's map in this case is provided by RxJava, and actually, if you have Java 6, for instance, you can use this operator because it will accept. In this case, it will accept anonymous classes instead of lambdas, basically. But there is a nice it's a good pairing with Java 8. RxJava and Java 8, you profit from the lambda syntax, which is much less verbose. So that's why I use this in my example. Right. So if I exit presentation mode, I will go back to the slides. Cool. Okay, so this was a quick example, and we'll see more interesting examples later on. But you may have a question at this point is, we migrated a service, it's all well and good, but this service was used by our REST controllers. So if the REST controllers are expecting in a blocking fashion to receive a big integer, now the service all of a sudden is returning an observable of big integer. How do you go and make it work, make it compile? And for that, the quick and dirty fix, of course, is to revert back temporarily, just for now, revert back to blocking. And there is an easy way to do that in RxJava, of course. It's just to chain the toBlocking method at the end of your stream. So when you receive the observable from your service, you call toBlocking on it. And then you kind of decide if the stream can return multiple items. You have to decide which one you are interested in. So you call first or last or single if you are only expected one item ever. So what's the difference? Basically, single, it will propagate an error. Here the X represents an error. If there are not exactly one item emitted. Okay, so the contract for single is I expect only one and only one item to be emitted. And if there are less than that, or if there are more than that, then instead propagate an exception. Yeah.
Does that mean that you have to wait for the uncompleted?
Yeah, exactly. So behind the covers, toBlocking and these calls made after toBlocking, they will wait for the underlying stream to complete, and then they will return directly the value to you.
So if that was a hot stream and never completed, walk forever.
Yeah, I'm talking about hot versus cold later on, but yeah, if RxJava works with in case where you have only one item, where you have a sequence of items, and also if you have infinite sequences. So, for instance, time-related ticks of a clock or mouse moving. But in the case of an infinite stream, you are right. You cannot block on such a stream. Yeah. What you could do is before blocking, you can use operators like take 5 or skip 5 or stuff like that to say, okay, I have an infinite source, but I'm only interested in that many elements, for instance, and then I will block and wait for that many elements to arrive. There is a little variation of all these operators, single, last, first, which is single or default. So here we say that in the event where the input stream is empty here, we'll provide a fallback value, and we want that to be emitted. And if there are too many elements, then it's still triggering an exception. Yeah, let's see an example of a controller where we need blocking behavior. Okay. So if I open one of the controllers, that would be the pool controller. We see that it's using observable services at one point. Okay. So just check out a later example. There's something missed. So a quick view of the architecture of the app. It's just a Spring Boot application with controllers. Yep. So a few REST controllers, domain objects, and services that depend on each other. So there is this pull service that is used to connect and disconnect users. And yeah, let's look at the index controller rather. So in the index controller that produces the home page of the application, kind of. We use this pull service to do things like connect a user and retrieve the number of users currently connected. And there is an example right here. I will change a little. Oops, sorry. So here we see that we call the pull service and the method mining users. And this method actually returns an observable of user, right? So you get a stream of the users currently connected to the app. And what we want to do is count them. So we call an RxJava operator here. And we want to, for now, do that in a blocking fashion. So we call toBlocking, and we say, OK, I'm only interested in the first value. And actually, I could use single here, because I only expect one element to be ever emitted. And we have other examples above. Here we notice another interesting pattern. It's the toList operator. So if you have a service that returns a list, I advise you to, when you convert it to an observable service, I advise you to not emit the list itself, but the individual elements. Because that way, you will have way more room for composition and doing individual stuff on the elements in your collection, rather than always manipulating the list. And if you actually want the list in its entirety, then you can always call this operator toList, and it will aggregate all the emissions and emit the list at the end. Once again, of course, if it's an infinite stream, then the list will keep filling, and you will never get the list because the stream doesn't complete. Right? And then once we have aggregated all the items, we block on the observable and get back the list. So this single operator here, this method, returns type T, in this case, a list of ranks. Okay. I'm sorry about the switching to presentation view. Put a shortcut up, and of course it does weird stuff like, ooh, weird character. Anyway, back to the slides. So we saw a little bit of blocking, single or default, this kind of things. Let's talk about transforming your data. So we saw FlatMap before. We saw map, before, and another very important operator to grasp is FlatMap. So FlatMap is a transformation as map was, except that it allows you to, the map function basically returns another observable, a little observable that goes in, that spawns from the main observable, and it can be like asynchronous processing. In the case of, let's take the example of a HTTP request. This would be a user, a parameter, and then the observable would correspond to an asynchronous request that is made to retrieve more data about the user. And what FlatMap will do is these internal individual observables, it will flatten them in the output stream. So for each item in the input stream, it will make an asynchronous call somehow, and that will produce a small observable, and take the data in this little stream here and flatten it into the output stream. And you can notice that it can be mixed, interleaved. So as the elements arrive, for instance, these two elements can arrive with a slight delay. As each element arrives, it gets emitted into the output stream. Does that make sense? And then you have also stuff like reduction, so reduce. The idea of reduce is that it will do a running computation on every item in your input stream. For instance, a running sum. So what it does is take the next element that gets emitted. Well, when the next element comes in, it will take the result of the previous computation and apply this function, reduce function, to the both of them. So at the start, the previous result was 0. So we have a new number that comes in, 0 plus 1 equals 1. Then a new number that comes in, let's say it's 2. 2 plus the previous result, 1 gives you 3, extra, extra. And at the end, once the input completes, you emit the final result. Yeah?
Is this equivalent to inject?
Eject?
Inject
Inject?
in languages like Ruby or Ruby?
Not familiar with inject, but yeah, the idea is that you have a function that takes as an input two parameters, the result of the previous step and the current value, and outputs. Yeah. And there is a variation of that that also emits the intermediate results at each step. Say, okay, the current sum is that. I wanted to talk to you about filter as well. So RxJava offers all sorts of operators to do filtering, and the most basic one is filter with a predicate. So here the predicate is the value a circle? And we see that from the input stream, it only keeps the values that correspond to this predicate. And once again, there is a notion of temporality. So if there is a delay between each notification, each new item coming in the input stream, if there is a 2-second delay between this item being emitted and this item being emitted, then in the output stream, you will get a 2-second delay here as well, of course. And yeah, that's basic filtering. There are also things like take. So take, you tell the observable that you are only interested in n number of elements, and it will unsubscribe from the input stream and only return you the first 2 elements and complete. And yeah, you can see that there are a lot of variation on these operators. So, for instance, take, there is also take until, which takes a predicate as a parameter, and you say, okay, I'm interested in all the values until this condition is met, and then emit that last item, the green one, and complete. And there are also, of course, operators to do things like counting. So this is very basic It's built upon the reduce that we saw earlier, and it's just doing incrementation of a counter to calculate the number of items that there are in your stream. Let's try to have a look at these operators in practice. So I'm in step 4. So this is from a workshop. So the code is on GitHub, and you can actually try to run the workshop and play with it yourself. I will put the URL later on at the end of the slides. So we learned about FlatMap. So let's have a look at an example of FlatMap. Here we have a service that is used to try to compute the capacity of our pool of users. So each user has a hash capacity. He has a powerful machine that can mine Bitcoin or Dogecoin easily or not. And what we want to do is actually apply 2 operators, FlatMap and reduce, to compute, to go asynchronously take the information for each user about his hash capacity. And with this information, we want to reduce that to the global capacity of the pool. So that's exactly what we are doing here. First, for each user that comes into the stream, we'll call the hash rate service and ask this service asynchronously for the hash capacity of this particular user. So hash rate 4 here, it's returning an observable of double. Okay. And maybe this is actually doing a call to a database asynchronously, or maybe it's something else, but this returns an observable. And then since we are using FlatMap, all these little observables of one item, they get flattened into a single big stream of doubles, which correspond to the capacity of each user that is connected to the app. So with that stream, we want to reduce it and do a running sum on it to obtain the global capacity of our application, basically our pool. And that's what we do here. So we initialize, the initial value is 0, and for given each previous step result and each new value that comes in, what do we return? We return the sum, so that is a running sum, basically. We learned about filter as well. So there is a search service. A search service where we have a find by name method. And the aim of this method is, given a pattern, find all the users that match this pattern. So here again, we are dependent on another service, the user service. And the user service gives us a stream of all non-users with find all. So if I look at that, find all returns observable of user. And since we are only interested in some of them and we want this subset to be emitted, we filter. So for each user in the source stream, we look at its display name, transform it to uppercase, and check if the pattern that we were given matches this particular user. So this is, as we saw earlier, this is the predicate function for filter. So this returns a Boolean, and then filter, if this function returns true, filter will emit that particular item. It doesn't transform, it emits the original item. And if the function returns false, then the item is just ignored. Right? So in effect, that gives us an observable of users still, which matches the return type. And this particular stream that we get here will only see users that match our pattern, our search pattern. Does that make sense? Yeah. Okay, and what we learned last is take and count. So there is also another service that has interesting methods. Ranking service ranked by hash rate. So this service is tasked with providing a ranking of the heaviest miners in the pool. So we have an observable here that is sorted by hash capacity. And since we want the particular value of one user, we can do a take until. So just keep the elements that don't match the user we are interested in. And when you find the user in the stream, complete the stream. Okay? And then if we combine that with the count operator, what it will do is count how many items were emitted before we found the particular user. And that gives us the rank of this user. Okay? If all the users are ordered by their capacity, and we let all the users before the one we are interested in pass, then count is the ranking of that particular user. So this is a way of combining observables and combining operators to produce something that was not offered directly by the API. And it's up to you to combine these operators to produce the results you are interested in, but it's very, very powerful. And once you start learning, once you start getting a grasp of all the most basics of operators, you will be able to read that kind of code pretty easily because it's standard. Yeah. Okay. So let's get back to the slides. So next thing is what RxJava kind of called side effects. And by side effect, I mean adding behavior to your stream, to your asynchronous processing, that doesn't change the stream itself. So doing things on the side. And it's very useful, for instance, if you want to log events. So if there are errors that come along the way, but you've put in place mechanisms to swallow the errors and return default value and stuff like that, we see that this is possible in RxJava. Maybe you still want to log that something went wrong at some point. Another usage is you want to do stuff with all the items in your stream before you will actually filter it or transform it. So before you lose the original value in its original form, you can do additional behavior on it with these methods. So these are the do on something methods. So do on next will be invoked on each emission. Do on error will be invoked if there is an error that is propagated. Do uncompleted will be invoked at the end of the stream, and then do on each is a way of doing all of the above in one go. So you get a notification, and then you work on it to determine if it's an error, a next item, or a completion. So I had an example of that. I don't know if it's really, if we have time to show it. It's very basic. It's just logging. When the user connects, we return the observable stream of Boolean to notify that, okay, the connection worked. But also with a do on next, we log the fact that a new user has connected. So that's the kind of application for this operator. Let's move on. Let's talk about combining different sources, right? So there are, let's say, 3 levels of doing that. So the most simple one is concat. Concat works on, in this example, 2 source observable. And it produces an output of the concatenation of the 2 source observables. So what this means basically is that it will start with observable A, emit all the items on A, and once A completes, it will start emitting all the values from the observable B, the second observable. So all from A, then all from B. Intermediate is merge, and we kind of saw that before, right? Merge as well takes 2 input observables, and it will emit items from the 2 as they come in. So if observable A emits 1 item, and immediately after observable B emits its first item, what we'll get as an output is the item from A, then the item from B. They are mixed in the output. And this rings a bell. This is actually what's behind FlatMap. FlatMap is nothing more internally than a composition of merge and map. Right? That is why FlatMap also has this behavior where the output of FlatMap can be mixed. And same as in FlatMap, if one of the observable terminates early because of an exception, then this exception is propagated, and this item here never gets a chance to be emitted. As I was saying, FlatMap uses merge. So if you look at the API, you will find a concat map, actually. And sometimes it's interesting to get the items in serial order rather than mixed like in FlatMap. And then there is the advanced combination, which also transforms. So if you have 2 source observables that are of different kinds, an observable of users and an observable of, cars. And what you want as an output is a combination of the 2, but transformed to like driver object, which is a composition of the user and his car. You can use zip, and zip will work with 2 input observables, 2 or more, and additionally you provide a transformation function. So it takes object of type A plus object of type B, and the output of that is object of type C, and that is the type of your output observable. So here what we have as a transformation function is you take the shape of items from A, you take the color of items from B, and you produce a shape of color C. Sorry? Yeah. Yeah, it will take pairs from each observable. So they have at least, it will stop when one of the two observables completes. But it's preferable for the observables to be of the same size, yeah, conceptually. It won't repeat when, for instance, if your first observable emits 10 items and the second one only emits 3, it won't use the last value for the extra items in A. It will just stop at 3, basically. Okay, so I will show you an example of zip in this instance. So here the example will be about statistics. Let's see. Oh, forgot something. So I want to check out this version of the code. So if I look at a service called stat service, we have a getAllStats method here. And once again, we are dealing with the entirety of our user base. So we call findAll on the user service. And then for each user, what we actually want to do is combine the user information, the profile and the name and stuff like that, with data about how many coins, bitcoins he found so far, and what is his hash capacity. So for that, we need to go to 2 other services asynchronously and say, okay, I have a user, give me its hash capacity. That's what we are doing here, hash rate 4. And okay, we have a user, give me his coin number, the number of coins he mined. And then we want to combine these 2 informations in an asynchronous manner to output a user stat object, which is a wrapper around all this information. And so here what we are doing is preparing the call to hash rate 4, preparing the call to total coins mined by, and then, sorry. And then we are saying that we will zip these 2 information. So this will be done asynchronously. As the information arrives, let's say the coin service takes like 2 seconds to answer. It will, the output of this zip will see an emission, a new item, a new notification 2 seconds later, because the combination is done asynchronously. So what we do is say, okay, what we are combining, the sources of data are this HR observable, this CO observable. So one is of type double, the other is of type long. And since we want a result of type userStat, we pass in a zip function, a transformation function that takes pairs of rate and coin, so double and long, and then creates a wrapper object, userStat here. And since we are in the FlatMap, we have access to, we have captured the user, so we can actually do that new user stat of his rate or her rate and coin. And that gives us an observable of user stat. So that's the idea of zip. Here we are still using FlatMap, and why are we using FlatMap? What would it do if we were using map? Maybe you ask yourself this question. If you were using map, what you would get is an observable of observables here of user stat. And this is not really interesting to have this kind of thing. So once again, FlatMap will take this inner observable and take all the items, or rather propagate the emission of all the items that come into these little inner observables. Okay. So that was an example of a zip. Now we are getting into the more advanced stuff, but also the more interesting stuff. Because so far we have been doing pretty basic things, and it's kind of, it reminds you, I'm sure, of Java 8 streams, except that Java 8 streams are about collections, so consuming in RAM locally and iterating over collections. And here we are dealing with a pool approach, so it's more general. But also RxJava has more to offer than just map and transformation function and counting. And one interesting aspect is retry, so live and let die and retry. So out of the box with RxJava, you get an operators like retry. What does it mean? Is you get more advanced error handling with this. So when you use retry and you chain retry to an input observable, and there is an exception that is raised, then what retry will do is prevent the propagation of this exception to the resulting observable, and instead it will resubscribe. So remember when at the beginning when I described the API, you have an observable and you have to subscribe to it at the end to describe how you consume the final form of your data. And here, composition in RxJava is based on these subscriptions. So operators like take2, it will just unsubscribe from the input observable when it reaches the count. And retry, it resubscribes. So it retriggers the generation of your data, kind of. And to retry, you can pass arguments like the number of attempts, max attempts that you want to do, or you can do some finer grained approaches like I only want to retry twice if I receive an illegal argument exception, and for any other exception, just propagate it. So yeah.
Those aren't the same residuals though, right? From the publisher?
No, there's a new publication of data, yeah. And actually, since we are talking about retry and this concept of resubscription and new generation of data, this is a good time to talk about hot versus cold. So this is a concept in RxJava and in reactive approaches that there are two broad types of observables. There are the hot ones and the cold ones. And what it means is that a hot observable, it doesn't care if someone is listening, if there is a subscription at the end. It will emit data anyway, like a clock ticking. And also, if there is no new data, but there are multiple subscriptions, multiple observers that are interested in the data, each observer will see the same data. So it doesn't trigger a new HTTP request, or it doesn't trigger a new creation of the data. It's just the same data that is served multiple times. And it's important, it's very important in retry, because we saw that retry, what retry does is resubscribe to the source observable. So if this source observable is a hot one, it will just replay the error again and again, unless there are new events that came in. So the retry will just do nothing, basically. You will say, okay, retry up to 4 times, and the 4 times it will see the same error, retry error, okay, and propagate the error. Whereas a cold observable is only publishing data at the point where a subscription to it is made. So until you subscribe to a cold observable, or an observable that is derived from a cold observable, until you subscribe to it, it just does nothing. It emits nothing. It doesn't even generate the data or call the source, the database, or the server through an HTTP request or anything. And then when you subscribe to it, there it generates a new data for you to consume. So if there are multiple subscriptions to it, there are multiple generation of data, generation of data. And this works well with retry. In this case, if the retried observable is called, then when retry is triggered, okay, I have an exception of type illegal argument exception. I will just unsubscribe and resubscribe to the source observable. Then here it will regenerate its data. It will do a second call to the database or the source of your data. And this time it could work, so the retry is successful. Yeah.
So are these stop subscription how to subscribe ahead of time?
This is in your code. Yeah, when you combine all these operators, if the real source of all that is called, at the end you have to subscribe to it, pass in an observer interface that you have implemented, and this is the point where the subscription is created. Okay, so that was retry and the side note on hot versus cold. And there are other ways of managing errors in RxJava. So we saw that the most basic one is implementing on error in your observer when you subscribe to your stream. But then you can choose to do things a little differently. So for instance, you have on error return that will fall back to a predetermined value if there is an exception. And once again, it can also be conditional on the type of exception that you get. So if upstream I see an illegal argument exception, return null, and if it's array index out of bounds, return 0 instead, for instance. So this is just a single value that gets emitted instead of propagating the error. But then the stream still completes at this point. So yeah, you have this kind of error management in RxJava. I'll talk about a last one a bit later on. Okay. So I have maybe a quick example of retry. Oops. So a quick example of retry. This is actually a bit convoluted, but I will try to have a look at it. Once again, it's in stat service, and it's the last block found by method. So this example is interesting because we had the case here. We had the case where it's kind of a hot observable, and the retry would do nothing. Yeah, I just talked through it. So the idea is here we have a create. So the creation of an observable from scratch, and create describes what you do when you get a new subscription. Well, what you do is emit on next on this subscription and signal completion. But before we put that in place, we would just use observable.just and capture this random number here. And that wouldn't work well with retry. Why? Because just will capture the value, and it will re-emit the same exception if there are exceptions. It will re-emit the same value if it's still the same value. It's kind of a hot observable. So one way to switch from a hot observable to a cold observable, there are two main ways. Either you create your observable from scratch. So create factory method will produce a cold observable, or you can also wrap an existing observable into a differ. So there's a differ method that wraps a hot observable, and it will recreate it from scratch each time there is a new subscription. So if you read the method very quickly, you see that we have a source of data that is a random generated number. We do a side effect here by printing the random generated number. We will try to asynchronously call the user service and skip that many users, so a random skip of users. We say that we are only interested in the last element from that observable. And if the last element is out of bounds, so if we generated too large a number compared to the number of users in our system, then we want to retry, so regenerate a random number and try to select a user in there. And lastly, if the 4 attempts still fail, we use the onErrorReturn method. Yeah, we use the onErrorReturn method to generate a default value, like it's kind of the null object pattern. So we say, okay, instead of throwing an exception, we will just return a default value with a negative ID, for instance, and random data in there. So that was just to illustrate that retry to work needs a cold observable, and how you can do that. And if you go beyond the number of attempts that you configured, then what you can do to avoid exceptions anyway. And yeah, just to have a look at, can you see that in the bottom? Yeah. The other signature for retry, it takes a function that takes an integer. So the integer is the current number of attempts. How many attempts have been made yet? And it takes also a throwable. So what kind of error just occurred? And you must return a Boolean saying, okay, should I retry or not? So basically, with this signature, it's a bit more fine-grained than the than the one above, where you just say, okay, 4 attempt max. With this signature, you can do both the number of attempts and conditional retry on the type of errors that you got, basically. Okay. So this is retry and on-error return semantics. So now we'll have a look at another part of the API, which is chaining, and how chaining can help us in day-to-day scenarios. So we saw already zip and zip with. So zip with is directly called from an observable, whereas zip was a factory method, a static method on the observable class, but the idea is the same in both operators. And in our example application, I was telling you earlier that we are interested in exchange rates, and we have dependencies to external APIs. So sometimes the user wants to know the exchange rate between the Dogecoin or Bitcoin and euros, for instance. And to produce that information, we need to call 2 external APIs. We need to call one API that gives us the rate between Dogecoin and euro and dollar, sorry. And then there is another external service that gives us the currency exchange rate between any 2 official currencies, so dollar and euro. And by combining the result of these 2 external calls, we are able to produce the exchange rate between Dogecoin and euros. And so what we can do for that is wrap a REST template call inside an observable.create. And that gives us an observable of the return value of each service that we can kind of map to extract the relevant part of the response, of the HTTP response. And then we can zip these 2 streams together, and that would give us the final exchange rate that we want. And sometimes hey, our product owner just arrived in the room while we were working on this REST chaining of calls, and he says, okay, we have an external service that it's a free exchange rate API, but it crashes far too often. So 2 times out of 10, it will time out. And I found another external API that does the same thing, but it's far more reliable. So okay, why don't you just implement that and call that instead? But it's a paid API, a pay-per-call API. So that's the key thing here. So the product owner goes on and say, yeah, and if you could go on and track cost of these calls and make it so it's only invoked when absolutely needed. So only invoked where the free API crashes. That would be great. You have 5 minutes. So we have 5 minutes, guys. Let's come up with a plan. The plan would be, so here it's from the workshop, actually. So I would try to code it in 5 minutes. But the plan would be to add a little method to the admin service to track the actual cost. And copy in the exchange rate service, copy the wrapping of the REST, the HTTP call, to adapt it to the new API. And then there is a pretty interesting operator that we can use, and that will save our life as a developer, which is on error resume next. So what does on error resume next do? Well, it's a bit like on error return, except it switches to a different observable if there is an error. Instead of propagating the error, it will say, okay, I have a backup plan. I will call this API. So basically here we have the observable that wraps the call to the free API. And if there is a crash, if there is a timeout in this free API, then by just chaining on error resume next, we can easily fall back to the alternative. And when we fall back, by chaining things like do on next, so the side effects, we can also easily produce a log that something went wrong, that we switch to a fallback alternative, and trigger an increment on the cost of calling this API. So I will show you very quickly the code for that. Okay. So this is basically, apart from doing the wrapping of this alternative REST API, external API, this is basically a matter of changing one single line of code. So this is doable when you know what you're doing in 5 minutes, actually. I just show you the end result anyway. So this is an exchange rate service. So here we have a REST template from Spring. And we have the URLs to three external APIs, 3 external services. So one that does the conversion from Doge to USD, one that does the conversion from USD to any other official currency, but it's the free one and it crashes far too often, and one that does the same but more reliably with a financial cost. Right. So this is the wrapping of the REST template call into an observable. So what we did is use the create factory method to describe from scratch our observable. And what it does is invoke the REST template with get from for object on this particular URL, and we want a double value. And when we get that from the server, from the external API, we will emit this rate into the stream and say, okay, the stream is complete. And in the case where there are exceptions in the REST template, so here, for example, there is a timeout, we transform this exception into a domain exception, meaningful exception to us, here, Doge pool exception. And we say, okay, unreachable service because of a timeout. So we propagate this in the on-error method. And if we catch any other exception, then we just propagate it as is. The idea is the same for the other wrapping of REST APIs. We sometimes extract a little bit more of data, but the idea is the same. And here we have the actual method exposed by the service, which is convert from Doge to a particular currency like euros. And what we had before using on-error resume next was just that without the switch here. But basically what we did is just add these 3 lines of code and say, okay, the observable that will produce the exchange rate from dollar to target currency, it's made of the call to the REST template the first REST template here. But in case of an error, we will log something, and we will resume with another, we will fall back to another observable. And we will do that only if we see a Doge pull exception. So that's why we wrapped our exception in a domain-specific exception. So basically, this code is saying, in case of an error, look at the error. Is it a Doge pull exception error? If yes, fall back to another REST call. If not, just propagate it as is. That's what this piece of code does. The observable.error just forwards the error. And then with that, we zip the stream that we just constructed. So this observable stream is error safe. We've made it error safe. And we zip it with the Doge to $1, and it's just a matter of combining the two rates together. So this is kind of unimportant, but you get the idea that, yeah, it's pretty powerful to be able to easily describe fallback mechanisms when you have this kind of possibility. Okay, I think we are almost out of time, but I will talk quickly about, so of course so far we've worked with error handling, retries, we've been transforming our data, etc. But there is still one point that is remaining from the beginning is we went the quick and dirty route, and quick and dirty fixes shouldn't stay ad vitam aeternam. It shouldn't go into production. So how can we clean up these controllers where we have been blocking so far? So in Spring, there is something that allows you to do asynchronous responses by returning a default result of T instead of returning T. So when you use a default result as a return type, you are instructing Spring, you are telling Spring that your service, your REST service is asynchronous. So what it will do is return the default result immediately, and Spring will kind of keep it on the side and say, okay, I will receive a notification when some data is available that I can give back to the client. But in the meantime, I can use all my resources, all my threads and stuff like that to process further requests. So if I have 1,000 clients all making requests at the same time, I'm not spawning 1,000 threads to deal with each request and have the thread wait 10 seconds because we are doing I/O and it's slow as hell. I'm using just one thread to say, okay, I get the default result, I put it in a queue, and I start processing other incoming requests, right? So in this sense, you benefit from asynchronous programming by having a more efficient usage of your resources. And you avoid too fine of a granularity that will spawn a ton of threads and become a synchronization nightmare and a context switching nightmare. So you need to somehow bridge between the Spring way of expressing asynchronicity and your observable services. So what you can do is actually create a default result and use a subscription on your service observable and say, okay, when I subscribe and when I receive a value, I will inject that value T by calling default result.setResult. And if there is an error, the corresponding mapping is to notify Spring of the error by calling set error result on the default result. So this is pretty one-on-one mapping that you can do between RxJava and Spring. And if you want to go even further than that, this behavior can be generalized in the sense that, at least in Spring 4.x, because in Spring 5, things will be reactive, supported from the get-go, so this will be interesting. But in the meantime, with Spring 4.1, 4.2, what you can do is use a return value handler, code a little simple adapter that will adapt observables to default results. And by doing that, by registering this value handler with Spring, automatically all your methods that return an observable, they will be reworked into returning a default result automatically. So you will benefit from that on all your services, all your REST services that return an observable. And yeah, a little word about testing a default result. This is still done with the mock MVC utility class, but you have to make an additional step to kind of trigger the generation of the value. So you call end return to get an MVC result object. You can assert that its status is always OK, because when you are asynchronous, by default, it will immediately return to you and say, it's OK, but I will notify you later with the actual result. You make sure that the asynchronous processing has started, and then you wait for it to complete by using mock MVC perform of async dispatch of this MVC result. So this is just a pattern for testing asynchronous services. And yeah, once you've done the perform, what you get is something that you can assert as usual. So you can assert the HTTP headers, the return code of your service, the content, the body of your response, and all of that. So yeah, this is also testable as you are accustomed to, except with a slightly different pattern at the beginning. And yeah, that's pretty much it. So takeaway for this session, I hope. We've done non-blocking code. We've done it without using any callbacks. And thanks to Java 8, we have a minimum of visual clutter. So that gives us a code that is readable. And as you become more familiar with RxJava operators, you will start to see patterns. You will start to see operators that you understand. And the combination of these operators gives us a readable and understandable code. And I hope you loved it. And yeah, this is the end. Thank you.